So I want to talk to you today about observability and a little bit about who I am. I have a cool Animoji. And you can find me on Twitter at Austin L. Parker. I'm a principal developer advocate for a company called Lightstep. And Lightstep is an observability platform that helps you understand the performance of your systems. So I use the word there, observability. And not everyone, you might have heard that. You might have seen it on Twitter or heard it in our talk. And maybe you're wondering, what is observability? Like, what is this all about? So observability, to me, is the answer to this question, right? How do we manage complex systems? And maybe a better way to start thinking about this is, what is a complex system, right? Do I have a complex system? Do you have a complex system? Because I think when you look around us and you look at kind of nature, you see a lot of very complex systems, right? I saw a really pretty picture this morning on Twitter of like a snowflake, just like a very close-in view of a snowflake. And the shape of a snowflake is remarkable, right? Here's this tiny, this interesting process that happens, due to chemistry and physics and all this other stuff that forms these beautiful, unique shapes. But there's also things that are, humans didn't create snowflakes, but there are things about nature that humans have sort of taken and built on top of, right? Like, we wouldn't be here talking to each other today, looking at these very nice screens, without electricity. It's a conversion of energy from one form to another, and because, we're all up here and we're, clever folks, we said, hey, what if we took that river and we built something around it, right? We made a tool. And we've used those tools to harness nature and then transform that energy into a form that we can use. You see something similar to this in the proliferation of software. Now, since I sort of got into programming years ago, typing away on an Apple II, writing little basic programs to keep track of my, baseball card collection, software's gotten a lot more complex, right? It's not just, 10 print, hello world, 20 go to 10. We've built a lot of tools and abstractions around our software in order to help us manage them and deploy them and run them. And that has created a proliferation of tooling, an explosion of tooling, right? If you look at this is the cloud-native landscape. So these are all tools that help you do things for cloud-native software, which is a fancy way of saying software that was written in the past 5 months. But you've got, you look up here, you've got, it's hard to see, I know, but you've got Kubernetes, you've got things like Envoy, Linkerd, Helm for deploying software, you've got a whole bunch of container runtimes, security products so that you can scan your cloud-native software, messaging queues and buses. And this is a lot. This is a lot for anyone to sort of keep in their head and know what is going to fix my problem on this sheet, right? And if I look even further, I see there's these other 2 boxes, and that's just serverless, right? So that's another full page, array of boxes that I have to know about. So all of these tools, we do them because we build them because we think it's going to make our lives easier, right? And we think that those tools are the solution to problems. But much like dams are sort of an abstraction that helps us, it's a tooling abstraction that helps us get electricity, the dam itself is not the electricity. Software tools are also abstractions on other things. They're abstractions over CPUs and memory and ways that you run software and containers that you run software in. You can also see this in how you write software, right? You've got high-level languages, you've got low-level languages. At a day-to-day sort of writing code, I think someone was talking about this yesterday, the abstractions you build are almost more important than the actual code you write, because those abstractions are how people interact with your code and how you maintain and grow your software over time. So an important abstraction that we think about is performance. Performance is, quite simply, to me, an end user, when I click this, I expect something to happen, and how fast it happens, that's a measure of performance. in the world of actually like operating larger systems or any kind of software, you traditionally have had this idea of there being 3 pillars of data that tells you about performance. So starting on the left here, we have metrics. And these, I think everyone's familiar with, right? How much CPU is my process consuming? How much memory am I using out of the total available to my process? Those are metrics. Those are a piece of data, a measure in time that tells me something that is important. The second one, logs. Logs are, if we go back to 10 print hello world, that's a log, right? We're having the software tell us something about what's going on. Now, you might see these as HTTP logs, how many tell me every request that happens. You probably have some custom logs in your software, right? Some event occurs, and you want to log that out. When you're debugging or writing software, what's the most frequently used debugger in software? It's a print statement, right? You print out what happens. And finally, you have traces, which are a way to look at every single request and look at all of the sort of hops from one service to another in that request. So I want to kind of pause here and ask, like, who here would you say, like, your primary role is to write software? Like, you are writing code. I see a few. Who would say their primary thing is running code, you're operating software? All right. And who's kind of doing some of both, right? You consider yourself like a DevOps practitioner. Okay. Now here's another question. Who here is like a manager or a business analyst or someone that is, your job isn't necessarily to write the code or run the code, but you're still interested in how it's working because all right, y'all back there, cool. So you're interested in this even though you're not the person that writes the code or runs the code, right? And that's because how your code is running, the performance of your systems matter a lot. It matters to me, as an employee of a company that runs a software product, right? Because I might not be going in every day and pulling tickets off of Jira and making commits and pull requests, but if our product doesn't work, then the demo I'm about to give you all in 10 minutes is going to go real bad. So I care about performance. My manager cares about performance. The CEO cares about performance. Everybody cares about performance. So a lot of us get to this stage, right? We'll say, like, okay, well, performance matters. I need to understand how my system is running, so I'm going to go buy some tools. I'm going to get all these 3 things, and I'm going to set up a bunch of dashboards, and it'll be great. Everyone can see how things are going. But I'm going to tell you that tools aren't observability. You can't buy it. Someone could sell it to you. If you say, hey, I'd like some observability, please, there are several people behind us that will gladly sell you a product, and they will say, yes, this will give you observability. But it's not really, that's not how it works. Because observability isn't just, a bunch of dashboards or having good logs or having metrics. Observability is about culture and about how you, not only as a developer or an operator or a DevOps person or a manager or someone that cares about performance, it's about how everyone is actually using that data and is actually making it part of the development lifecycle at your organization. So, and when I say culture, what do I mean? Well, people have done studies about stuff like this, right? They've looked at tools and they've said, hey, what's the best way? What tool can I use to make my software run better or prevent defects? There was a study in 2008. This involved Microsoft and several other companies and researchers, but they found that the biggest indicator of software quality was organizational structure, was the kind of development team you were running, right? It's about, are you agile? It's about, are you listening to people? How are you kind of handling concerns? Are you sort of changing direction too fast or too much? More than anything else they were analyzing, which is looking at code churn, looking at code complexity and coverage, looking at dependencies and other QA processes. It's about your organizational processes, your operational processes, more than it's about like any one tool. And that is what I mean when I say human-centric observability, right? It's the way that your people and sort of the organization structure, your decision-making, and how you're bringing all this back into the software development lifecycle, that is really what it's indicative of how you think about performance and how you manage performance. So you have to solve these problems through people as well. The scope of our team, though, isn't just enough, right? Like if I come in and I say, well, I want observability, and I'm going to get this for all my engineering buddies on our engineering team, or maybe all my ops buddies on my DevOps team, I think that's too narrow of a scope. I used to work in DevOps specifically. I led our DevOps team at a company, and we were basically responsible for these big QA environments. And developers kept coming to me and saying, like, look, tests will fail, and we don't know why. We don't have enough data from the system to understand why our tests are failing. So is there anything you can do? And I said, well, we aren't really monitoring their servers at all, right? We don't know, yes, we see this test fails, but we don't know the state of the overall system at that time. And so I went out and I evaluated several options, and I came back and said, we should pay this vendor to use their monitoring solution. And so I went through all this, set it up, had beautiful dashboards. So you could go in and you could find at any moment, like how much CPU, how much disk space, set up alerts and conditions and all this sort of stuff to give us what I thought was observability into the state of our system. And at first, people were thrilled. They were like, yes, this is great. I can see what's going on. And then I noticed after the first couple weeks, like people stopped logging in. People stopped using the tools. And I went back and I said, hey, what's up? You all really thought you really wanted this. And like, well, it doesn't actually provide any value to us. It's not telling us anything. It tells us, yeah, that things are bad, but it doesn't tell us why things are bad. We don't have enough data. The data isn't correlated well enough, And this is a pattern that happens at other places, right? There's a company called Segment. Has anyone ever heard of Segment? A couple people? So they do analytics. And they were having a problem where they were starting to have a lot of system failures, right? The reliability of their system was dropping. And that was causing their end users, their customers, to be very concerned. And they were like, hey, we trust you to provide a reliable system, and it's not happening. And so they were given sort of an ultimatum, a directive in their words, which is you need to have a level of certainty, and you need to back that certainty by data that anything you do is not going to cause an incident, is not going to cause downtime. And until that happens, that's what you're going to work on. And the reason why is because they had this very pervasive lack of safety in their words. Developers were making a lot of choices, and all those choices, most of those choices were bad. There's a lot of wrong ways to do things and only a couple right ways to do things. And this is primarily an expression of fear. Now that fear can be a motivator, or that fear can lead you to sort of paralysis in how you make decisions and how you ship software and run software. And the solution to this, one of the solutions to this, was for them to think about observability and to think about how were they actually collecting data and how are they getting that data to make decisions. So Segment's problem was, hey, I've got a bunch of users that are unhappy. And so when you start to think more about your data and you start to think more about, what am I actually monitoring for, you should think about who your users are, right? They saw, I have these actual end users that are, complaining. And I say there's, 3 types of users you need to think about. One is going to be your external users. And this is straightforward, right? These are the people that use your software, that are buying stuff from you or adding things to, clicking buttons in a cart or banking or whatever it is your software does, right? There's all sorts of software out there. But these are the people that are interacting with it sort of at the top of the iceberg, right? They're the people interacting with it, clicking buttons and doing stuff, and they don't really know much about the rest of it. There's also internal users, and internal users are kind of twofold. So if you have a microservice architecture, if you have a service-oriented architecture, and you have multiple teams that control multiple services within your system, then these could be people that are depending on your service as an actual service dependency, but these could also be people that are the managers and the project managers and the business analysts and the CEOs, right? These are the people that depend on your service to work, and they consume it in a different way than your external users do, but they still are important users who you need to think about when you're building an observability strategy. And finally, there's engineers. Yeah. I tried to make the metaphor work. But these are the engineers, right? These are the people building the software. They're writing the code. They're shipping features. They need to know how the service is working, but they also need to be an audience that you think about when you're deciding how to build this all out. Ultimately, users are users are users are users are users. They actually all kind of care about the same basic things. They care about the throughput, they care about the latency, and they care about the error rate of any part of your system. Because when those things start to waver, that's when you start to get problems, right? When your error rate is too high, that means that either you're going to hit everyone, right? You're going to hit the person clicking the button in the web app. You're going to hit the person who consumes your service as a dependency, because now they have to deal with those errors. When you have throughput issues, someone's sending you too many requests, then that's going to affect latency for all those people. If you've read the SRE book from Google, they call these golden signals, right? Latency, error, throughput. And by focusing on those as sort of the thing, the basic indicators of service health, then that kind of leads you to some takeaways, right? Some notions about how to improve this. So human-centric observability helps you build empathy with those users, right? I was talking to some people at one of the open spaces yesterday, and one of the things that came up when we were talking about monitoring and application monitoring was, how do I get devs to care? Like, how do I make people care about this? Well, to go back a step, right? Like, you need to think about all of this as a factor of how it impacts your end user experience. The people that are clicking the buttons, adding things to carts. Segment is a good illustration of this. They weren't concerned about bad performance because a number on a chart told them to be concerned about bad performance. They were concerned about bad performance, and they were concerned about reliability because they had talked to their users, and their users had said, look, you need to care about this, otherwise we're going to go somewhere else. We're going to take our money and leave. So measure what they care about, right? They care about latency. They care about the error rate. They care about, hey, can I do is this reliable when throughput is high? They care, can I click the button when it's Black Friday? And another thing to think about here is consider, has anyone heard the term sampling before? A couple people? So sampling is a strategy by which you reduce the amount of data you need to look at by throwing some of it away at the beginning. And you can do this in a mathematically rigorous way and get a set that is inclusive, over however many requests will theoretically show you everything that happens in it. However, sampling does throw data away, so you can miss outliers. And those outliers are so they're not only like things that are actually happening to someone, right? But that's data that you could be using to make better decisions about what's going on in your system. That's data that maybe you really, 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 really want to see when it's like 4 o'clock on a Friday and you're really just trying to close that last bug. So think about how sampling and about how your monitoring systems are kind of taking data and aggregating it from you. Human-centric observability also helps you build empathy across teams. So there's a good mix of people here, I feel like. I've seen some people say, yeah, they're just devs. They're primarily ops. Some are DevOps. Some are, sort of in the middle or in a, related support sort of thing. So by being able to have sort of standard things you talk about, right? By being able to talk about latency and throughput and errors and these sort of golden signals, then that is something that everyone can understand on some level, right? And it's something that I can understand on my front end, or my client side team. It's also something I can understand on my back end team. That's data that both groups of people can look at and agree, yeah, we're all measuring the same thing, right? Has anyone ever had to deal with vanity metrics or people, I've seen this at places that have sort of like hostile, let's say, or non-blameless retrospectives where, it's kind of a fight, right? Like there's a big outage, there's downtime, CEOs get mad, everyone gets called into meetings, and now you have to justify like why it wasn't your fault, which isn't fun for anyone. So as a response, you'll see teams create just like these synthetic endpoints on their application that prove that they've got, 5 nines of uptime or 4 nines of uptime, right? It's not actually measuring anything that matters. It's like a different endpoint. It's not connected to the actual work being done in the service, but they can point and say like, oh no, this dashboard says we're good, so it's probably their fault. And that sucks, just quite frankly. Like that breeds bad blood and people like stabbing each other instead of working together. And no one wants to work in that environment, right? People get burned out, people get sad, people get mad. Observability is about having these sort of common touch points, right? So that everyone's on the same page. If I have a system where I have instrumented it for observability, then I'm going to have the same sort of metrics, the same sort of indicators from every service about what the health of that service is, and that's going to be across the board. So there's no more finger pointing. There's no more, do this or do, everyone has their own idea of what the truth is. It's a shared reality, which I think is something that most people could agree is sorely lacking in our modern discourse. So, finally, you can build business empathy through this sort of human-centric observability. If you're trying to go make the case for, hey, I need more time to do refactoring, or I need more time to kind of do gardening, right? I need to improve the health of this part of the code. Like, how are you making that argument? Think back to the segment one, right? The segment quote I put up before, they use data. They made it a hard requirement that they had to use data. You had to show, point out the thing that says, hey, this is going to be better if I do it, right? And you can use that sort of in the reverse. You can point out and say, like, well, look, here's where the problems are. It's this part of the system. So people generally aren't, I would say people aren't not doing this, right? Like, I think everyone to some extent knows, like, hey, these are the problems, right? This is sort of the dark area of the code. Here be dragons. The last time, an engineer went in there, we didn't see them for 5 days, and they came back a changed person. They went into, like, the Sith cave or whatever, right? But people aren't, like, that's not because they're, because these people are mean or bad or don't like you or are deliberately antagonistic. A lot of times it's because we have too much else to do. We're too busy, right? Like, you have 14 different other pressures at your, as a developer, and you want to get those done. You want to, you got to fix this bug over here, or you've got someone harping on you about adding this feature, or you're trying to ensure that your little slice of the world, the part of the world that you can control, remains in your control. And what people effectively tell you is like, oh, but you're responsible for all this other stuff, and that creates a lot of stress because people don't feel like they can control all the stuff they're responsible for. And that's why I say, like, this is a way to build sort of that empathy in your business, in interactions between managers and teammates, because you're able to all start talking about this with the same words, right? You're able to use the same language to discuss performance and what it means, and you can use that data to point out and have objective decisions about why things are the way they are. And it also can be easier to kind of go and encourage someone to say, hey, yeah, if I make this data accessible to everyone and it's easy to use and interpret and understand, then those developers that maybe traditionally haven't been thinking about performance, now they can because they're being given insights in a very easy to understand way. So at the end of the day, everyone's just trying to kind of do their job, do their 8 to 10 hours and punch out so they can go and have a real life. Our tools and the way we build software shouldn't keep us from that, right? Like I have been, who's been up at like 3 a.m. because something broke, right? You got paged. That sucks. I was, like a couple years ago, on my, December 24th, we had a release that we had committed to on the 25th. I'm in a car driving down the New York State Thruway, and I get a call that, hey, something broke in QA. You need to like drop what you're doing and remote in and fix it. And so, by the way, December 24th is very cold in New York, and I'm desperately trying to get Wi-Fi from like the Thruway rest area. It sucks, right? But the person telling me, hey, drop what you're doing, like they weren't doing it because they were evil. They were doing it because like they had questions that needed to be answered and they didn't have the information they needed, and so they had to rely on me as the person that knew it. So all of this, I have said a lot of things and hopefully given you some stuff to think about. And now, you might be asking, hey, how do I solve this puzzle, right? What are the solutions here? So I would like to spend a few moments going through, how am I on time? Bad? There's a little thing down here that hasn't been working, but seriously, how am I on time? 2 minutes. Cool. So we'll do this real quick. So I have some code here. I want to know what this code does. This code calculates the Fibonacci sequence. I can take a project called OpenTelemetry, which is a open source package that lets me quickly and easily add instrumentation to some code, and then I can observe what's going on. This is something that you could do yourself fairly easily. This software will be in beta here in a couple weeks. Right now, I'm using an alpha version. So if I go now to a terminal and I run this, live demos, folks. You gotta love them. So what I am doing now is I have a script running. I can actually drag it up here and show you. We can drag it up here and show you. Oh, we can see that there's an error. What did I do wrong? Name OS is not defined. Okay. So now I am actually calling this, and you see that there's a lot of logs. Now these logs aren't telling me much on their own, right? If I watch, so what I can do though is I can log in to Lightstep, which is a thing we know, and I will be able to see the data coming from those requests I made. And I did all this without actually having to really modify anything. I added some imports. And I can see, like, here's the request as it goes through and does this recursive call to calculate the Fibonacci sequence. Now, I can easily add this to all my services, and it will show those calls as they move across from one service to the next to the next. If you would like to see more about this, I will have some papers that you can pick up and go do this yourself. But this is how easy it is to start to get tools that will let you figure out, like, hey, how long is everything taking? Well, I can see it right here, and then I can analyze this data and make better decisions about what's going on in my software. So how do you do this for yourself? Well, 3 things. So first, you need to incentivize this, right? You need to kind of go and tell people about all this cool stuff you saw here and bribe them if you have to. But it can make it easy for people to adopt these tools, and they will adopt these tools, right? The second thing is, we talked about service level indicators like throughput and latency and so forth, but when you're talking about service level objectives, which are kind of the things that those feed into, you need to make sure those are talking about like actual goals, not just like, hey, the CPU needs to be under whatever, or the memory should be under whatever, or even like I should be able to put so much traffic through this endpoint. It should be, I'm putting traffic through the endpoint because that's how people are checking out or people are adding things to their cart. Make sure you think about sort of these businessy things and from the perspective of your end users as you're building your software and thinking about performance. Finally, avoid selfish tools. Avoid things like logs that only you understand. Avoid having like one person go out and build all these metrics dashboards and then nobody else knowing them, how they work. Try to shoot for things that are a little more generally applicable, things that everyone can sort of get their hands on, go in, poke around with, and that try to focus on outcomes over just like, here's a bunch of raw data. Ultimately, you're doing two things with observability. You're improving those SLOs, so you're making the performance better, or you're restoring them, like when there's a fire. And you're doing that not just for you, not just because you want to, but you're doing that because you want your users and everyone on your team to have a better experience and be generally happier with life and themselves.